All right, so talking about a little bit further, diving further into this idea of object creation in JavaScript. This is one of the things that, once again, I've said this before, and you probably heard it hinted to you from MPJ as you watch some of those videos, is that this is something that you will get burned if you pretend like you're coming from. So if you come into JavaScript from another language and you don't understand its intricacies, you will get burned when you're trying to do this type of stuff, this object creation. If this is your first time understanding like object-oriented programming and seeing it for the first time, like that's all the better. I think that learning it through JavaScript's lens is amazing because it's weird and it's tricky and it's quirky, but like once you get used to it in JavaScript, you could easily move over to another language and learn more about the few things that are different here and there. I think it's a little bit different coming, but somebody else can correct me if I'm wrong. I'm biased because JavaScript was my first programming language. So for me, this idea of creating objects is beautiful and eloquent. Maybe not so eloquent. Okay, so what we're actually going to do is we're going to, okay, so remember I gave you this link yesterday to JavaScript Mini. You should have at least filled out probably the first two problems in recursion from yesterday. Well, everyone's like, well, we learned about recursion yesterday. Doesn't that feel like it was a couple weeks ago? I feel like we were talking about recursion, but that was just yesterday. So, and then this keyword, I basically gave you the answers to this one, so you can fill this one out too. You don't ever need to submit pull requests on the minis unless we ask you to. That's sort of just like extra. It's extra follow along material is really what it is. But today we're going to be working in the constructors and the JavaScript 2 mini repo that you have cloned and downloaded, dissected, and everything, and started working on. We're basically going to be able to work in this constructors file today. That's what we're going to be talking about, is more on the constructor function, and even more so on the this keyword as well, as we go about continuously learning how to get this stuff done, how to create objects. And that's the idea behind me giving you that video series from MPJ last night, is that that whole series, I think there's 7 videos, is absolutely phenomenal, and it's everything you need to know to get stuff done. So today we're actually going to be talking about an inheritance pattern called prototypal inheritance. Now in JavaScript there are 4 different types of patterns that you can use to basically create some sort of constructor function that creates subclass objects or child objects from that function, right? So we're going to talk about how we achieve this with the prototypal syntax today, okay? So what we're talking about is prototypal inheritance. And what this does and what it's going to lead to is what the class keyword in JavaScript is doing under the hood. All right? So let us dive in deeply. Okay, I'm going to open up my textual editor. Okay. All right. So and you guys, this is one place where you don't have to follow along right now. And I'll ask you to do something in just a minute. So it's not like you need to just frantically type to keep up. So inheritance, examples. Okay, here we go. Awesome. Let's bump that up a bit. I changed some settings. I caved and I changed some settings in my text editor. So you're going to notice some things are a little bit different today. Okay, so bear with me. I feel like you'll still get the same quality, high resolution DPI editor experience on my screen. I don't know. Okay, and let me check out Zoom's chat so that you guys have that open and available. Okay. If you send me a message in Zoom, I will get it. Okay. Awesome. Sweet. So when we built our first constructor functions yesterday, we were building it with like the people whatchamacallit, like the, okay, yeah, let's do it like a user. Okay, so this is a really, really good use case for this. Okay, so when we're creating objects in JavaScript, basically what we're doing is we're providing a template for that object to be created. Okay, if I'm going to create an object literal, I can do something like this. Const my object equals, and how many times have I done this so far? A lot, right? So it's like, this is just kind of annoying. Okay, well, it's just creating object literal. So name equals Ryan, whatever. Okay, so it's not, and what I mean by annoying is that this is kind of tedious. If I needed like multiple users to be created and stored somewhere in a database, so think about Facebook, they have billions of users, right? Potentially worldwide. And so these users, they come in and it's like, what if I had to write, you know, take what's from that user and then put it to an object? Like, obviously we're going to write a computer program that does that for us. And one way we can do that is we can create an object from a constructor template. You can think of it as like a template, okay? So you say, so if I was going to do this, if I was going to create like my user model, it's going to be a function user. And remember, the capital U right here is not syntax. Okay, your code, you could do this with just any function. We use it in JavaScript as convention. So it's like good practices to name your constructor functions with the capital letter, okay? So I want you to just be aware that this is not going to break your code. I can create an object from a function as long as I use the new keyword, right, if it's lowercase, but the convention in JavaScript is that uppercase. Okay, and so for every user, we're going to have some sort of options object that comes in. And options is just very commonly used like word. This could be anything. This could be credentials, right? We'll leave it at credentials for now just so you can see it. So if I was going to log in as a user to a website, what are some properties that my user object needs to have? What do I need to be aware of? What do I need to give the Facebook form that I log into in order to log in? Usually it's like a username and password, right? Oh, sorry. I just tried to create an object literal. So I just like equals this. No, that's not what we're doing here. So we're saying this dot username equals credentials dot username, right? So like whatever object comes in here when we call user with the new keyword is going to be, we're assuming it's going to have these properties. So we're saying, hey, this is our template for user. We're gonna basically allow these users to come in, okay? And then we're gonna say this dot password equals credentials dot password. Credentials is a hard word to type over and over again, so I'm just gonna call it creds. Cool, like your street cred. Alexander, are you in this Zoom meeting? We're doing, we're in this Zoom meeting. Yeah, there we go. There we go. He's like, so what are we doing? Yeah, cool. Retina signature, sure. Some sort of retina signature. I don't know. I don't know how I'd program that in here. Let's just keep the user object. Like normally, your user object will have like this dot first name equals cred. So let's do this. Dot first name, this dot last name equals creds dot last name. Facebook, in the case that they want to know everything, they're like this dot phone number, right? But we won't be that big brothery. Okay, so we can basically use this user object to create as many users as we want. When a user hits some sort of button on the Facebook login page, it's going to fire a function that says, hey, go create this user with these credentials. And it's going to take in that input, and it's going to pass it through this function. And so when I say like const my user equals new user, and we pass it that information, the form that you fill out all your stuff with on Facebook is going to collect your username as whatever your username is going to be. And let's say that that's Ryan at isawesome.com. Password 1234. First name and last name. So the special thing about this object is that it is created from a template, okay? That's what's awesome here. And we've used the new keyword. So if you want to sort of think about and conceptualize what this new keyword does, you can think about it like this. Essentially, we are saying this, whoops, becomes an object.create, okay? And then we return this. That's pretty much what new does under, I mean, there's a lot more to it than that, but it's saying, hey, create an empty object, like a brand new object that inherits from the global objects prototype, and return that object, okay? And then it's setting, so this becomes this object, right? The object that comes in, these credentials get bound to this keyword as an object, and then that object gets spit out like this. You can think of it in terms of kind of what's going on with memory under the hood. And I'm not going to pretend to be some sort of memory expert, but you can start to think of your code in terms of this. Okay, so like variables would be on the left-hand side, but this is the left-hand variable assignment location, and then your memory, like where that, like what's actually going to live in here. And the way that Ben Nelson likes to teach about memory, what I like to sort of think of it as, you can think of memory as like a giant tabletop, and then eventually, if you have too many things on that table, you start stacking things on that table, they're going to fall off the table, right? So there's a limit to how many things you can put on that table, right? And so what this actually does under the hood, when we call user, okay, we're saying call user, and we have the initial, like this keyword, okay? And then it takes this and it's going to go and create a new object, okay? So that this keyword will be simply pointing to some sort of like new object over here. And that's going to then set all of these properties on all these properties that come in from creds, because we have another object, right? So our creds is this object right here that we're passing up to it. And so that is an object that needs to be stored somewhere, right? So that's kind of what's going on here. And then eventually, my user will, that's essentially what's being pointed to. So my user, gets all of these properties, all of these things assigned to it, okay? All of these values, okay? Because that's what, I mean, that's what's going to happen here. And then eventually, so this is used to simply create the object, and then when we return it, this keyword will essentially pass those properties down and then get garbage collected. This object that came in gets garbage collected, and then what we have is a reference to a new object that our function created, where we can reference it at my user, okay? That's a really high level, like, understanding of what's going on under the hood. And once again, I'm not going to claim to be some sort of like low level, like down to the metal memory allocation expert. I'm not a Rust programmer. I don't build browsers. Data type of cred would be, well, what do you think? What's your first intuition there? What does this indicate that cred would be? It's an object, right? Which, if you said array, it's just a more specific type of object, but it's not an array in this case, so it's just an object. Yeah, I mean, we could get semantic, but we're not going to. Okay, and so if I were to, so this essentially, let's run Quokka and let's see what happens. Yep, and so if you look, you can see that we have a new object that inherits properties, right? So if I were to do this with another user, let's say const another user equals new user, okay? And they're going to get everything that I get, but it's going to be Fred, and my last name is not, last name's actually Hamblin. Haim, what the crap was I thinking? Hambline? What am I doing? Can't even spell my last name. I actually got docked off of a research project in college. I actually got docked for misspelling my name once on the top of my paper. So that's that's just so you know, the more you know about me. Yes. Okay. Yep. So we're passing, yeah, exactly. So Ira said it right. We're passing an object through user, and then it's basically taking this keyword, because we call new, and it's creating a new object in memory to store some of this stuff so that it can then return that object out of this function. Okay. So that's one way you can sort of think about this type of stuff. All right. Okay. So now, now that we have a reusable piece of code here, the way that this actually gets to be useful, it's like at this point, it's like this seems just a little bit less tedious than writing objects over and over and over again and storing them, right? That would be pretty annoying, but this is a little bit less annoying. But it's still kind of like, I mean, you have to call this code and pass it information. It's just kind of a weird thing, right? So where this gets a little bit more handy is when you have something that says like, so this dot say name equals a function. So when you're actually using a function, and just say, we'll just say console.log, hello, my name is, what's my naming? Name. Oh, shoot, this dot name. All right. So now what's cool is that I can use this object or this function in different contexts, right? Because the this keyword is bound to whatever object gets called with it. Okay, so this keyword comes in with user, and we're basically assigning it to that. So if we would assume that if I called my user dot say name, it's going to print out, hello, my name is, undefined. Oh, it's username, first name. You guys did not help me out with that one. Okay, hello, my name is Ryan. Name was undefined because I didn't define it. All right, let's check it out. Okay, and then I could do the same thing. It's like I have a bunch of reusable code now, right? Because I could create as many users as I want. And then, whoops, another user, derp. And then it's going to be right there. It's going to, yeah, so it's undefined down there because we're console logging and it's not returning anything. Let's see what happens if I just do this. And it's just console logging. It's still going to call it, and it's going to be just fine the same way as it is up there. So hello, my name is Ryan. Hello, my name is Fred. Reusable code. This isn't new. You guys saw this yesterday. How are we all feeling about this? Let's just do a quick poll, like 1 to 5. Like, you understand how to use the new in this keyword. So we'll just do poll from 1 to 5. Whoa. Yes, we're going to get to the prototype. It is different. We're talking about prototypes today. Okay, so scale of 1 to 5, how are you feeling about constructor functions and the syntax related to creating objects from constructor functions? 5 being you could teach it to a new learner, a JavaScript learner, somebody who knows at least what you know about syntax for now. And then 1 is like, I have never even seen this before and I don't know what's going on. I have forgotten everything you told us yesterday. Okay. That's good. Awesome. So yeah, the syntax is pretty straightforward. Let me just walk through it one more time so that we have some clarity. We create a function. We only capitalize it because it's convention, right? And it's very similar to like new array. Once again, we're going to stick to this type of syntax, and it'll help us understand a little bit more about a few things. Okay, and then what else was I saying? Okay, so this gets assigned when we call the new keyword, and it gets assigned to the object that comes in, right? And then that object then creates returns an object that has a reference to a variable in memory. Okay, so my user goes ahead and gets created from user. Right? And then we have access to all of these things right here. This sayname function lives on every single version that we create. We're copying this property over every single time we create it. That's exactly what is going on under the hood. So if I were to take this stuff and put it in a browser, it's a little bit easier to see inside of Chrome than it is in a node environment. So let's go ahead and run this in Chrome. And I want to see my user. Okay, so check it out. My user, let me give us some real estate here. Okay, so look at this. We have this say-name function that's copied over as a property on this object, okay? And then we also have first name, last name, password, and username. Awesome. We stored this user, and the user can say its name, okay? Really awesome. So I could go ahead and I could call my other user. What did I call it? Another user? What was it called? Another user. Okay, same thing, right? We copied over all those properties. Now the problem with this is that you're kind of copying over a property every single time that you do this. And this function could potentially be a function that like returns stuff from another function or makes some request to some server somewhere to get some information, right? And that's going to be really big and clunky on an object. It's not necessarily something that you want to always have happen in any case. So JavaScript built into this object, every single object that's created in a similar fashion, they built this idea, this paradigm called the prototype. And the prototype itself is an object, okay? And that object is the object that basically tells any other object that gets created, it tells all other objects that get created what is available to them. And it gives our objects the ability to say, hey, do you have a function that you know about called sayName? And if it doesn't, it can look up the prototype chain to another object. And that object can be like, I don't have that. Let me look up the chain for you. And then eventually at the top of the chain, if that function is defined, where it's defined in the prototype chain can pass that down to the child object, okay? So when we're using the object's prototype, we get this special object that lives under the hood. And that special object allows us to basically gain inheritance over everything that we need inheritance over, okay? And I'm going to get into a lot, like, don't worry, it's like, oh, Ryan, what did you just say? This is not trivial stuff, okay? Object-oriented programmers come from all over flocking to JavaScript, and they're like, I don't even understand this, right? And it all has to do with this prototype object, okay? Oh, and I wanted to show you that with Chrome. Incognito. Nice. Dang it. Come here. Come here. Okay. And my user. Okay, that's me. All right. So the way that we have sort of a secret special keyword that's built into all objects that live inside of a web browser. Okay, so web browsers built a way to be able to access the object's prototype directly. In not so much of a, it's not a language thing. This underscore proto underscore underscore, it comes from the ability that, or the ability that objects need to be able to be used by the browser, okay? So we're actually going to, so if you look at this, there's really nothing useful for us here right now. If you look, there's a constructor. We're not really, I mean, it's like this user was a constructor, right? So you can think of it this way. My user, so my object that is Ryan object, my user's prototype is the constructor, okay? So you can think of it that way right now. Okay, so if you look at that, you can see that right away. It's like, oh, this is a constructor function. And we know it's a constructor function because we used what to create it. We use the new keyword. Not uppercase. Remember, uppercase is just a convention. So uppercase is just the convention. So we know it's a constructor by, like, we see it and we're like, oh, must be a constructor because it's capitalized. But the computer knows it's a constructor because we use the new keyword. Okay, does that make sense? I think that's the best way that I could clarify that. We as programmers know that it's a constructor because we capitalize the first letter. The computer knows it's a constructor because we use the new keyword to create an object from that constructor, which is why my user's constructor, or my user's prototype, is this constructor function. Okay, so it belongs there. It's stationed there. So instead of doing that whole like rigmarole where we had like a left hand and a right hand assignment, you can think of a prototype as sort of like a sidekick to our constructor function. And this prototype is going to, we can basically set some properties on this, and anything that's a child of our parent all the way down basically can inherit from that. And you can set individual prototypes on children objects if you so choose to do so, which is something that's really, really cool. So you can do this and you can say, hey, potentially this child object may want to delegate down its properties to other children. Okay, so we're getting into this idea of like object and property delegation. And if that's the case, then we could actually program its own special prototype that this object right here has no clue about, nor does this one up here, right? These objects do not know about this child prototype. However, every child in the prototype chain knows about its parent prototype. Okay, so that just pretend like this arrow. I can actually undo. Yeah. Oh, dang it! Didn't want to undo that far. So every object within the prototype chain knows about its parents' prototypes. Okay, so they get sort of chained together like this, right? It's like, oh, I have everything that you have because you're my great granddad, right? I have those bright blue eyes, right? Or something like that. It's not really inheritance in the same way that it may be in other paradigms, but it is delegation. This parent object will delegate down its prototype's properties. Okay, so, and there's a beautiful diagram that Alexander just posted in Slack. In fact, I want to hold on to that and throw it into notes. So maybe that Medium article, JavaScript object hierarchy, will, yeah, I'm going to check out that Medium article after this. So we just DM me that article, Alexander. That'd be great. That'd be great. Yeah. You can tell it's like almost Friday, right? So, okay, cool. So where is this useful? Where does this actually come in handy? And we're not actually using this prototype yet, FYI. So we're actually going to rip this function out. Instead of every single time that we create a new object, we're going to just add its properties to that. We're going to rip this bad boy out of here. So I can say something to the effect of user.prototype, and I might get burned here, but we'll see. Dot say name equals function. And I only, for reference, what was our function doing? Hold on. Our function was just console logging the name. So this is what we need. I need this stuff right here. Okay, get out of here, keyword. Get out of here. Okay, so fruit dot prototype dot say name equals und function. Okay, fruit. Why did I call it fruit? It's because my notes say fruit over here, and we're going to get into a fruit example. So, okay, check it out. What is the difference between having what we had seen earlier and this? I'm about to tell you. The difference is we're storing this stuff offloaded somewhere else. It's not being stored on the my user object directly. Let's look at it under the hood, okay? And look, our functions continue to work as they were expected. So we gain that inheritance, okay? It's like, oh, we have the username, password, first name, last name, and this prototype method that we just chained onto our user's prototype, okay? So anytime that we create a new user, okay, we're actually chaining a method onto that user's prototype. And so any child or any user that gets instantiated with the user's properties gets that access to that prototype. Okay, let's look at it. If you don't believe me, that's fine. It's about to be demonstrated. Let me do a hard refresh so that we clear our cache, our browser. Okay, cool. And then I can say, so let's say my user real quick. Awesome. Okay, where is my user? Dun, dun, dun. Where, oh, sorry, I meant to say, where is say name? Where's the say name function? It doesn't live here anymore, right? It's not on the object's properties itself. However, it is on the prototype, okay? Let this sink in for just a minute. Let it breathe. All right. Fill up your cup with coffee. This is a big deal. It's a big deal because this allows us to do so many things with object creation. And it allows us to build things like AngularJS and EmberJS and Vue.js and React.js, all of these client-side frameworks. It allows us to build complex applications because we can continuously use the object's prototype where it doesn't store it in memory the same way that it used to. It doesn't have to copy this object, this function, right, over and over and over again. It only has to create it once. And so when we go to reference it, it's going to say my user.sayName. I'm going to say my user.sayName. Do you have on your object, when you were created, do you have something called sayName? And then the code is going to be like, I actually don't. Let me look at the prototype. Let me look at, where I could potentially know about this stuff. And it finds it, and it's like, oh, that's actually a function. Let me call that function since that's what you're doing, and I'm gonna do what that function wants me to do. Oh, and I'm gonna also give it everything that I know, everything I own, right? Everything I own is this username, password, first name, last name. So when it gets called, in one instance, sayName is pointing to the first name of new user being called by my user, and then sayName in the next instance it called is getting pointed to Fred, right? The this.first name. Okay, this is anyone who continuously knows about or learns about JavaScript will be exposed to this, and you'll continuously be able to learn deeper and dive deeper into the fundamentals of these things. Alexander, I'm not sure. If the prototype had a variable username, would it call that variable? Do you mean if I set a username like first name here? So if I said yes, so it would most. Let's check it out. So let's say const username equals username, or equals Barney, but this keyword is referencing something else. But if I wanted to say username, yeah, potentially I could do stuff like this and hard code values in. Now this is not very reusable because we have hard coded a value. Is this what you were kind of getting at? Yeah. Chris, I'm not sure what your original. I'm sorry, I missed your comments there. I'd love to know more about what you're trying to ask. And then Alexander asks, "Is JavaScript's object chain kind of like a red-black tree or a linked list?" I don't know. It's probably. I mean, yeah. Truthfully, I don't know because I don't know all of the intricacies and the details around a red-black list right now. That's something that I'm studying more up on. Linked list, I think you could think of it in that way. If it were to be like a linked list, you would have to have like a ref to an object, right? So a node points to another node, and then but the thing is yeah, because user gets the original prototype and passes it down, so it could go down the chain like that. But if you had like each node could potentially have like infinite amount of sibling nodes, then it's not quite like a linked list, right? The prototype had variable username. Would it call that variable? Okay, we just went over that. So as a rule of thumb, should we not put functions in the constructor user and put functions in his prototypes? When we use the class keyword, it does this for us. It puts them on the prototype chain. You could build them on the class. It basically does a lot of this offloading for us and optimizes the crap out of our applications like this. So with React, people generally find putting functions inside constructors so they could bind it to the class object. I do that all the time in React. So yeah, and Vartan, I think we went over that idea. So if I think I get what you're saying. You could definitely locally scope. This is just a function like anything else. We're just setting it on an object. So it's the same thing as like saying my object dot foo equals function, right? But just imagine that the foo or my object was a giant prototype object that had a lot of other cool stuff assigned to it, like scopes, and there's a local and a global scope, right? So like, check it out. This prototype knows about the different scopes that are available to it. This prototype also knows, and then yeah, so just remember this __ proto is not part of the JavaScript language. It's built into your web browsers for the use of the web browser and should not be used to override your object. You should never go in and program something. And the reason is that could easily be gone tomorrow. There could be a standard that comes out that is like, we have this new thing, and you'd have to go in and it's also just kind of dangerous to access it that way. It's just best to use syntax like this. Okay, so everyone go ahead now and open your text editor. Create a person constructor like you did yesterday, and add a method to that constructor's prototype that prints out the first name of that person. You can have as many properties as you want, but I only want to spend 5 minutes doing this. And then we're going to get into a little bit deeper conversation about this stuff. So create a constructor function, a person constructor with at least one property. Okay. Chain a method called speak to the person constructor. Okay, and then instantiate a new person from the constructor. Method called speak that prints hello and the person's name or something. Just anything. It could be anything you want. Just prints a string. Just prints a string plus a variable that's on the constructor. Okay, instantiated person anew from the constructor, and then we'll move on from there. So 5 minutes. We will reconvene shortly. I'll leave this screen up, but I'm going to pause the video. So because yesterday I think we had a long video where there were like absences. And so I'm getting better. Every single time I do this, I get a little bit better, just a little bit. Okay, so I'm going to pause the recording and let you guys do this for 5 minutes. Ooh. Okay, so what were we able to come up with our projects, with our little person constructors? Did everybody get to an object that printed out, and you were able to chain on the method and call it from a new object? Something like that. Oh, you're good, Barrett. You're good. Okay, let's do it right now. Let's walk through it because it'll only take just a couple of seconds, a couple of minutes maybe. So function person is a constructor. Okay, I know as a developer that this is a constructor because of the capital P, right? The computer will know that it's a constructor because of the what? The new keyword. Beautiful. Okay. Now, if I want to chain on some sort of prototype method to this, I could say person.prototype. So find that prototype, beautiful little object that lives there. And it's going to belong to this constructor. And I'm going to say dot speak basically becomes a function. Okay, I want to show you something too real quick. Let's get rid of the function keyword. Let's try it like this. Ooh, nice. Why is name not defined? Nice. I'm glad to hear you were on the right track, Barrett. Oh yeah, I should probably put this in there, but it's still gonna break. You guys are too clever for me. Well, I made the mistake, but okay, let me see this. Hello, my name is undefined. Why is name undefined? This context, why has this context changed? What changed it? What made it weird? It's not bound, but why, Ira? Why? What's the idea behind that? What's the big idea?
Is it okay if I talk? That's just easier.
Yes.
Okay, so basically what happens is that this refers to the context when it is being called. So if you don't bind it to its origin, it'll shift. So basically, if you bind this to when you write it, in this case, the object or the constructor function, then later when you talk about this, the computer still knows that that's what you mean by this. But if you don't do that, if you don't overtly say like, hey, this is going in this context is forever going to refer to this thing, then it won't know later.
Okay. So what could I change on line 13 to fix this? And what I was mainly leaning towards was actually the difference in syntax between using a fat arrow and the function keyword as well.
Oh, in that case, then I have no idea.
Okay, so what I was leaning towards was this, but yes, you're absolutely right. I could potentially do this if I use something like bind here, and then I might need to pass in this context, but I would have to figure out exactly where I need, like what context I would need, and I would probably need another object in order to do that. Or yeah, so it'd be another object to inherit that property from. But you're absolutely right. Everything you were saying was right on point. But the difference is with the fat arrow key function, we actually get a blocking scope here. It creates its brand new lexical environment that does not really allow it to inherit automatically from the outer environment. So the arrow function, you can think of it in terms of it doesn't have access to this keyword until you explicitly tell it to. Okay, but for us, all I had to do was go back to the original, the OG function keyword, right? So that'll definitely trip you up later on. There are some things in the class syntax that we actually now have that allow us to do arrow functions and still have the binding, the implicit binding. But they are more involved with like how a class constructor gets built. So for now, just remember, and Grant sort of hit it on the foot, same with Julian and John when you guys talked about the arrow function. So the function keyword and the arrow function are to both be used in JavaScript, okay? People are all about, oh no, down with the function keyword. I'm saving so much time writing my fat arrow functions. And what's silly about that is you lose capability with the arrow function. The arrow function is a beautiful brand new feature that we get with ES6. However, it's designed differently than the function keyword, and the reason being is because they both behave differently, and that's important to understand. Okay, so I wanted to go over that, but yes, thank you so much, Ira, for jumping in and telling us. But yes, if I wanted to fix this, I would have to simply bind my context, but I would probably need another object to bind it with. So, cool. All right, now this becomes in handy. This all becomes a little bit more handy when we're chaining on prototypes and when we're actually using inheritance. So let's do this. And take I'm going to just comment everything out here. And then what I'll do is I'll save all of this as a secret gist for you, okay? Okay, so let's move into the sort of the meat and potatoes of what we're getting at today. So I alluded to the fact that I have some awesome examples from Ben about inheritance patterns and kind of some things that we can do to learn more about new objects and creating child objects, okay? So let's pretend like we had okay. So let's go through this. So let's pretend like we had like a fruit. Well, we're not going to pretend. We're actually going to have it. So we have a fruit constructor. Okay, and this fruit constructor has a bunch of properties on it. And those properties would be something like, so the type of fruit equals options.type, or let's give, yeah, so options need to come in here. What are we going to say? Like fruit attributes, attrs, cool. So we're going to say attrs.type, okay? Attributes being like the attributes of the fruit. We're going to say the fruit has a name. This dot is ripe, can be either a Boolean or whatever, but we're just going to say attrs dot is ripe. Okay, and then this dot calories equals attrs dot calories. Okay. Now, since I have this parent object constructor, okay, that's going to create a bunch of different child objects from it, we're going to bind a couple of things. Yeah, we can make some bananas. Cool. So we're going to combine a couple. We're going to bind a prototype function. So we're going to bind a function to this fruits prototype. And this is something you can actually do to follow along with me now. So if you want, go ahead and follow along as much as you can try and keep up, okay? So I'm going to say the fruits prototype gets a function called shipped, okay? And when we call this function, we're going to have some sort of destination, okay? And we're going to say just simply console.log this idea that shipping fruit, we're going to say shipping this dot name to our destination. Hopefully by now, this template literal string syntax is very familiar to you. If you're ever needing to combine variables and strings together, like just native strings, yes, use the interpolated syntax here, the template literal string syntax. And these are backticks, not quotes, okay? So quotes would be the button that's next to the return keyword or key on your keyboard, and the backtick would be the button that's the top left button on the tilde on the keyboard, okay? All right, so from this object, we can actually, this is where things start to get really awesome, okay? We can actually create, okay? Nope, it's not this dot destination. So it would be just destination because I'm going to use some fruit and call dot shipped, and I'm going to feed it a destination argument. So we'll say Arizona. We ship a lot of fruits to Arizona because it's Arizona. I don't know. We'll go with that. So that's why. And some fruitoir is not defined. It will be in just a minute once we create that. Okay. So everyone should pretty much be able to be at this stage now where we have a parent fruit, and I'm going to give you this whole entire file today to be able to draw inspiration from. And I can actually give you another file that's really cool that uses this type of syntax as well. Prototype, this is Prototypal Inheritance. Welcome. Okay, so just FYI, once again, this is what we're doing. We're using prototype inheritance, okay? And it's a big deal to understand this. Once you get this, once you understand this after the many months here at Lambda School, you'll be so proficient in creating applications. And it's like React abstracts a lot of this, okay? So what if we wanted to build that chain like I was talking about? And we wanted to build our fruit object, but then we have multiple children of that fruit object that are in and of themselves created and inherit, and all of these properties are passed down from granddaddy fruit. Okay, so we have fruit, which is the, like, I don't know, you could think of it like human species genome, whatever. But this fruit would just be like a plant, right? We could even go as far as up the chain as to call this like a plant, and then fruit, and then you have vegetable, and then you have whatever. But for now, we're just worried about the fruit being the most parent, and then children, and so on and so forth. And we wanted these to be unique objects in and of themselves that have, let's put their own prototype on them. And then obviously the parent has a prototype that these objects can look up into if they need. Okay. Remember, what is a prototype? What type of primitive type in JavaScript is a prototype? What is it? Ding, 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 ding. It is an object. Okay? So that's kind of what we're going to be building here. We're going to be building multiple instances of fruit that rely on their very, very own constructor. Okay? So, oh, I need to clear that and get my mouse back up. Hey, it didn't clear. There we go. Okay, so we're going to build new constructors. So let's do our banana constructor. Okay, so I'm going to say function banana. I always do a space after that. It's lame. Okay, so now I'm going to have some sort of like attributes get passed to banana that specify like what it's going to actually be. And then let's say this dot do monkeys like it. That's a question, camel case question. And we're just going to say adders. I need to find this. Adders dot do monkeys like it. It's a Boolean, like yes or no, true or false. Okay. So now, what's cool about this is we can go and create a new banana. Create our new banana, and I'm going to say something to the effect of with our new banana. Let's give it all of these properties and see what happens. This is where man, it's so cool. Okay, so I'm going to say const new bananas. Am I spelling bananas right? Banana. That's always like a hard word for me because it's like, who knows? New banana. And we're going to give it an option of, oh, it's got to be an object because that's the way I'm referencing it. So I'm going to say, do monkeys like it? And I'm going to say false. And here's a problem. If I give this all of this stuff, let's break the next line. Okay, cool. So all of this stuff, and it's going to auto just correct for me. So I'm going to say this dot type. Crap, I needed to go this way. Okay, we'll just do this real quick. Cool. And that commas, but they're actually strings of stuff. Type is a, what is banana? Vine? No, tree. It's a tree type. That's where it grows. And then the name of the fruit is banana. And then we'll say is ripe, and we'll say almost. Is ripe could be like a stage. So let's actually give is ripe like some sort of enumerable property here of like so this could essentially be three different things like not ripe, ripe, and almost ripe or something. So we'll just say almost, right? And then this calories will just be a number. So like each banana will have what, like 10 calories. Okay. Get rid of this keyword and the equal sign. Sorry, bear with me for that. Or thanks for bearing with me through that. Okay, cool. So now if I actually log out my new bananas, all we get is just inheriting. We passed it all this stuff, and like what's going on? We're not actually inheriting anything from fruit. Fruit does not know about my banana. So let's fix that. I taught you two methods yesterday that you can use to explicitly bind objects to one another. Two JavaScript objects. There's a third one too. We talked about bind a little bit earlier, but there's two. They're very apply and call. Call and apply. And what are the differences between call and apply? One takes a special type of argument, right? Okay, so here's what's going to happen with the new keyword. When I call banana, new is going to treat this like a constructor. And so any other constructor that I'm trying to inherit properties from within, it can be called from this function as well. So I can say something to the effect of fruit.call. And I can pass it the context that I want to be bound to, and then the additional attributes that I need supplied to this. So I'm going to call this object something else, like that's specific to banana. So I'm going to say banana adders. Attributes, okay? So these are specific to this. So what I need is to pass it the context that I need something bound to, and then the additional properties that need to be bound. What did I just do here? What in the crap is going on? All of a sudden, I have a banana that has a type tree, name banana, it's is ripe. Is ripe, let's actually change is ripe to Boolean. I hate the array idea. So we'll just say it's a true or false. And right now we're going to say false, because they're shipping. They're going to be shipping soon. So what did I just do here? What did I just accomplish? Well, essentially what I accomplished was this. I asked banana, when it was called and instantiated, to inherit all of the stuff that comes from the parent prototype. So anything, this stuff right here, that gets called from banana, oh my goodness, I didn't save that previous example, but I can certainly do that. I just don't want to close this file. Wow, that's bad news. Okay, cool. So this right here, I just realized I'm on line 2. It should be like line 150. Okay, and I'm going to fix that right now while you guys think about this for just a second. So give me this. Let me just put it aside. If you fast forward this part in the video, like really go real fast, like double speed, it'll be super cool looking. Almost done. Okay, now I take what I had here and I apply it down here. Oh, I did it again. There we go. Okay, fun. Okay, and we'll keep things separated and nice and neat for you. Okay, cool. So what just happened here? Well, we achieved an idea, or we achieved this principle called inheritance, okay? And we basically are delegating or telling our banana constructor to be concerned about anything that our fruit constructor needs to be concerned about as well. So when we create this object, we actually get a banana object, okay? So excuse me. So now I actually should have, if I have done everything right, I should have a shipped method on the prototype that I can reference. So if I call .shipped and pass it a destination like Utah, because Utah needs a lot of fruit, let's double check and see. New bananas. That shipped is not a function. That shipped should be a function. Oh, I needed to do something. Hold on. Let's double check this under the hood real quick. I might just have a typo somewhere. You guys will be the first to tell me what it is. Yeah, there is no method. If I created a new fruit, I should be bound all up. I should all be bound up. Monkeys do like bananas. Okay. It might, but I don't see how that. I just had this all working with the examples. Oh, you know what? One of the biggest things. Wait, so Caleb, do you have yours? Yours is actually calling the shipped method from the prototype there, even though you called it from new banana. Because I know what has to happen here, and it has to do with me. So by nature, what I'm trying to do, no, because it should be inheriting. But if I did something to the effect of banana dot prototype equals, and then I need to actually tell this prototype to exist, and then pass it the fruits prototype. It's funny, it's saying, oh, destination is undefined. Yeah, so duh. Okay, so that works. Okay, that's what I needed to do. So Utah, shipping banana to Utah. Okay, so this is the last step that I was missing. Okay, is this idea that my prototype, my banana prototype, there isn't true, and this is a very good gotcha. Okay, this is a very big gotcha, because automatically this stuff is not just like assigned. Just because we bound our banana constructor to our fruit constructor with the call method, it does not mean that the prototype gets automatically assigned to it as well. Okay, we created a new object from banana, and we simply just bound some of the actual attributes of that object. Okay, so the properties get bound, and that's great. Everything inherits that way. But with the prototype, it behaves a little differently. The prototype needs to be set explicitly as well. So we need to actually create a prototype from within. Once we are in the child, now it's like this. It's like our drawing from earlier, where we had this prototype, where it's like if I just had created like a method and used it in the sense that I had inherited straight from fruit. So this is fruit, and this is fruit's prototype. So FP, okay. And I created this inheritance right here, right? Well, I created this idea that I could chain a method on here, but I didn't call the new keyword from here. It all has to do with from where I called the new keyword. And that was on banana. I'm just going to call it ban. And then so I have a new keyword called from here, not from here. And so it needed to create a prototype. And so right now, banana, it basically created a shell of a prototype, right? And so what I did is I explicitly set the banana prototype to actually reference and inherit from the fruit prototype. Okay, so now I have my very own banana prototype because I delegated it. I told it to. And that does not happen automatically in JavaScript. You will get burned if you're creating child objects like this, okay, from separate constructors. Okay, let's create another fruit constructor. In fact, now that you have seen this, well, no, because you'll get a lot of practice with this with the mini project, and then you'll be able to move into the main focus with it. Okay, so now that you have seen this, it's going to be pretty easy to go ahead and get us a new. Let's do it up here, and let's give us a new fruit. Who wants to give us a new fruit? What line is fruit defined on? It's defined up here as a function. So it may be, kiwi's good. Cool. So it may be that you have a lowercase issue. Okay, let's call kiwi. Let's make a kiwi constructor. So kiwi gets kiwi attributes. and then we will lowercase that k. Okay. And what's an attribute that's specific to a kiwi? Looks, birds named after it. I don't know, what would I say? Has seeds. All fruit has seeds, right? Hairy, fuzzy is fuzzy. Cool. And then we need to, okay, so bring this up underneath banana and bring this kiwi down, and let's actually make sure that kiwi.prototype is that of fruits prototype as well. Okay. All right, and then we can say something to the effect of new kiwi. And we'll say new kiwi and is fuzzy, and it's true. And this should not be false, this should be true. Monkeys love bananas. Okay, and then calories, we'll say 100. No, there's probably less than that. Let's say 0.7, and we're gonna use a function to decide. And it's a tree fruit as well, so I wanted to get a separate type, like a berry or something, but that's fine. And this is gonna say new kiwi. And so now if we call just like this and ship out our new kiwi to Alaska, Alaskans need their kiwi, shipping kiwi to Alaska, we're good to go. Okay, so we're bound up, we're all good to go, right? Now, normally what would happen is like all of your constructors and prototype methods that need to be existent on the original call would be like in their own file. And then you would have like functions that, you know, get called all over the place. So now, let's build another function, and we're going to build it on the fruit prototype that calculates the calories. So we're going to say fruit.prototype.calculate cals equals a function that's simply just console logs for us. Console logs out calories in this dot name are, and then we'll say this dot calories, no, not calculate calories, calories multiplied by just some arbitrary 200 number or something. Cool. Fruit, man. So now, if I look at bananas, we have two. So we're shipping our bananas to Utah. We're shipping our kiwis to Alaska. Now, if I call new bananas and say dot calculate calories, I need to know. Oh, it's called cas. Find calculate cas and change everything to calculate cals. Cool. We're going to just instantiate that. Just call it. And look, so calories in a banana are 2,000. So our math may be a little off there. Let's give this a period. Okay, so just 20 calories per banana. And then if I called my kiwi with the same thing, we have a different result, right? Because kiwis are a little bit higher in fat content, I guess, or calorie content. So check this out. Like I'm using inheritance here in the sense that I'm creating objects from child-like constructor functions, right? So like my constructor functions, I have 3 constructor functions in here. I have banana, kiwi, and then I have a constructor function that is a parent. And so I'm achieving this idea of inheritance by explicitly binding what my constructor function gets set to when I call the new keyword. I'm saying, hey, get everything that fruit has, okay? So banana, you're gonna inherit, all the properties of the fruit are gonna inherit down to banana, okay? And so I have a new context for every single one of my fruits. Okay, so this is really important to understand that this is how we can achieve this idea of parent-child relationships, objects that delegate properties down to other objects. And this is a lot of work. Like I've only done 2 objects here and have 2 methods, right? And so what if I actually wanted to achieve this like a very specific a very specific thing. So I'm going to chain on to bananas its very own method. So now bananas prototype is going to receive dot some sort of method. And I'm going to say check, I don't know, check who likes it. Okay, and that equals a function. Remember, I'm using the function keyword so I can, achieve inheritance there. And I need to now say something to the effect of console.log if monkeys like it. So what I'll do is I'll say if this dot do monkeys like it is true, and I'll just explicitly set it to true for now. You could have simply just said, you could have just left out that part if you wanted. Okay, and then, but I'm just going to do it for now just so you understand what I'm checking there. And then if it is, I'm just going to say console.log the string monkeys, monkeys love, and then I'm actually going to interpolate because I want to use the name. So I'm going to say monkeys love, they freaking love it, this dot name. Awesome. Now let's check this out. Check who likes it. And I'm actually just going to get rid of what's going on here. Just call that method. And give me back my console. Monkeys love banana. Monkeys love banana. I need to put an S after that. Because we'll just call it a single banana. Cool. All right, so monkeys love bananas. What do you guys think would happen? This is the point that I'm going to try and drive home to you right now. What do you all think would happen if I simply now tried to call new kiwi.checkWhoLikesIt? And this may be a trick question or may be very straightforward depending on how you're thinking about it. Let me just do this message. This message, and just everyone just vote. Do you think it will work? If you do think it will work, give me the fast parrot. If you think that it will not work, give me the red X. If I try and call new kiwi.checkWhoLikesIt, will it work? Don't be afraid here. Don't be shy to vote. A lot of people are putting the red X, so probably anyone gonna gander a guess with the it will work? Just one guess? It's not. It's not going to work. Okay, so let me get rid of these so my console is a little bit clearer to understand and reason about. It's not a function. It does not exist explicitly on that prototype, and we can walk up the chain. Okay, so let's look at what we have done here. We have our fruit, capital F. Capital F for fruit. We have our bananas, and we also have our kiwis, okay? The fruit has a prototype that has a couple of methods on it. Some of those methods that we called, I can't scroll up right now, let me scroll up. Okay, so it has a prototype that has two methods on it. Well, one method, let's see. Okay, so it has shipped and calculate calories, okay? And then what we've done, so we have two methods. We'll just call them S and CC. Awesome. So those exist on that prototype. Kiwi was called with the new keyword. Banana was called with the new keyword as well. These were called with two different contexts, but they both inherit the prototype. So when I call kiwi.shipped, it's going to say, hey, Kiwi, do you have anything called shipped in your inventory, in your prototype inventory? Kiwi's going to be like, nah, I don't know anything about that. Let me go ask my dada. Let me go ask fruit. And it's going to walk up the chain. It's going to go, oh, do you have it? Yes, let's use it, and let's use it with the Kiwi context. So it'll print out that lovely message that goes for it. But what we did with banana is we also created its own prototype. We actually don't have a prototype necessarily explicitly set. Actually, do we? Did I do that? Yes, I did, because we needed to inherit. So we both have prototypes. So ignore my last statement as I was saying it. Okay, So we both have prototypes, but Banana actually has a check who likes it function. So I'm just going to call it C. Give me that back. Little stylus. So it's going to say, hey, we have C on there. Kiwi doesn't necessarily have any methods like available to it on its own prototype, right? And so we can call banana.shipped, and yeah, it's going to walk up the chain the same way that Kiwi would and be like, hey, I got something here, give it the banana context and print it out, okay? However, we have added a new method here. So Kiwi cannot go up the chain and find this check who likes it function, okay? It doesn't know where that is. It's actually on banana, on a sibling. They don't know about each other's prototypes. They only know about the parent prototype, okay? That's what these children objects know about. And this gives you a way, so I'm gonna actually, no, I don't wanna screenshot that, that's ugly as crap. Okay, so this gives you, as a programmer, a way to get your very own inheritance from a parent object. So you could set as many attributes on this parent object as you want. And then we are binding, explicitly binding what these attributes get, okay? And so when we call new banana, and we create a new banana, this is the instantiation of banana. Instantiate of the single fruit siblings. Okay, that's good to know. We're instantiating it and we're passing in these functions. So if I wanted to say with Kiwi I could create a method that says, is Kiwi true? Now, how could I potentially gain access to this idea? So okay, so what could I do? So what could I do to explicitly set this stuff? What could I do in order to say, hey, new Kiwi, like let's see, monkeys love kiwis. How could I achieve that? I have two methods that could potentially do it for me, and let's see if I can do this before I get burned heavily. The problem is that we're not achieving a new context. So that was a very specific function that I just bound it to. So this is a very once again, it's a contrived example. But what we will say is, yeah, so do monkeys like kiwis? Because that's what we're after here. Do monkeys like it equals true. Well, monkeys, wait. This dot do monkeys like it should be, okay, so hold on one second. One second. So there's a problem with my logic here. So that's the problem. So let's look at this context. Let's actually take off this call real quick. I'm going to do something and then I'm going to explain it. Okay. So let's look at, come on, I have syntax error. Okay. That's crazy because I am passing it. Oh, duh, derp. Okay. Okay, let's try this now. Oh, okay, awesome. Okay, problem solved. I had an error, a big user error. I was actually trying to explicitly set who likes it. Okay, so now in two different contexts, okay. So here's what I've done: is I've taken this method that's very important to me that lives on the banana prototype, and I have said, hey, call that method with a new context, with a Kiwi context. So is this starting to make a little bit more sense as to why this is useful? A couple of people asked yesterday, why do I care about this as a programmer? Shouldn't it just all be a bunch of for loops and programs like that? And shouldn't I just be able to create objects and things? Well, this is why it's important, because you can call a method that lives on a prototype of an object somewhere with a completely different context. Okay, you can say, hey, I want to pass, and you can explicitly set that. And this is one reason why it's important. It's not the only reason, but this gives you so much power because now kiwi did not have our kiwi fruit did not have this method, but I can still use it. Okay, so that's why it's super duper awesome. I can still use it, and I can do some logic here now. So let's say if we want to know more about like monkeys loving bananas and kiwis, so let's do some logic here and say if, let's say if our this dot do monkeys like it is true, or, so the or operator tells me I can do another condition in my conditional. I can say if this dot is fuzzy, so I could say, oh no, what I'll do is, what do I want to do? So there's only two conditions here, but I want to make this like, okay, so this dot is fuzzy or this dot, do monkeys like it? Monkeys probably would love kiwis, but if I want to say, or this dot is fuzzy, look, we only get one print statement that monkeys love bananas. They actually don't love kiwis. And so what I could do is I could say else console.log. So if that means the opposite of these conditions, right? Else console.log monkeys hate. Let's just assume that they hate stuff. This dot name. Monkeys hate kiwi, and then an S. See the power of this now? I can tell, I created this function somewhere else, somewhere different than kiwi, okay? But I'm reusing the power of the function without actually having to recreate that function. I can just pass it a new context over and over and over again. And I could come in here, and obviously this conditional logic is only set to kiwis and fruits, kiwis and bananas. I could say something to the effect of like, do monkeys like it on every single one of my object? And if they don't like it, then print something else and like print what's being called. But look at the conditions. Look at what's going on here. I'm calling this function that lives on whose prototype? The banana's prototype, right? So once again, guys, just soak this in and be a sponge. I know I told you to try and follow along, but I got carried away with this big, large example. But this is how this stuff is achieved with prototypal inheritance. Okay, so from now until lunch, I want you to actually work on the JavaScript mini exercise that you guys got yesterday, which is found at this URL. And I want you to go into the constructors task, and I want you to figure out how you can achieve this with just this syntax, okay? You're not trying to use class keyword. You're not trying to do anything else. And then after lunch, you're going to work on, in your partnerships, you're going to work on your, let's see, JavaScript 2. JavaScript 2. Well, pick up where you left off yesterday after lunch with your partner. And then start on, as soon as you can, start on the prototype file, which is big. There's a lot here. So we have multiple objects here. And this is actually really, really fun. This is very, very much the way you could potentially go about creating like a role-playing game, like a video game in JavaScript. So yeah, this is really, really cool. So, okay, so remember the two things that you're working on right now. Right now, you're working on the JavaScript 2 mini exercise alone for the next 15 minutes, okay, before you go to lunch, and try and get a solution to the constructors.js file. So try and create that animal cat relationship there, okay? And then after lunch in your partnerships, so I want you to actually stop where you were yesterday and start working on the prototype.js. And then this afternoon, it'll only take me 10 minutes or so to describe how to do this with the class keyword in ES6, because you'll have been so proficient in doing this already. And so we're going to use our same fruit example at 2 p.m. Pacific, and we're going to go over that class keyword. And then what I'd love to do is sometime tomorrow, maybe late afternoon tomorrow, have a full solution to all of these things and walk you through it all. And then maybe get a solution to, well, I want to give you a solution to check matching leaves because that's a huge algorithm. Okay, so that'll be fun too. So yeah, there's a lot to work on here. This is all really fun. And this is where programs start to get built. You have started your week with sort of a fundamental understanding of like JavaScript and what it is, and you have gotten more ammo in your ammo box. And now it's like, oh, I got to go and build a full-on program. And so once you actually get to, this is so cool, it's so nerdy that I love this, but once you get to a point where you're actually creating new objects, you can see those objects get printed out to the screen and you get a visual representation. Yeah, so let me actually post this as a gist, a secret gist, and I'm going to keep it saved on my computer. And I want to add, yeah, there we go. Okay, cool. So now we have all of this, and let me actually clean it up here a little bit. So I'll just stop the recording here, and I'll clean it up so you have like headings. So I'm just going to say, like person constructor here, and then I'll clean it up so you can read it a little bit more clearly. And I'll keep this video open for the next 15 minutes, but I'm not going to record anymore. Okay.